Welcome to this explainer. Okay, let's jump right in. Today, we are completely stripping away the syntax to focus purely on the conceptual logic of writing your own functions. And right off the bat, I want you to think of this not as some advanced programming wizardry, but as a completely straightforward, everyday tool for engineering problem solving.
Now, here is a practical dilemma literally every single engineer eventually faces. Picture it. You're staring at your data, and you just need a very specific calculation done over and over again. So you have to ask yourself, do I waste time hunting through a massive library, crossing my fingers as someone else out there built my exact mathematical operation, or do I just bite the bullet and write the formula myself? But before we answer that, let's clear something up right away. The logic we're about to cover, it is identical in both R and Python. So we are officially putting aside all language-specific syntax today. No brackets, no specific commands, none of that. Whether you happen to work in one language or the other, the underlying blueprint of how you actually construct these tools is exactly the same.
So, what are we actually building here? Well, a function is nothing more than a simple machine. You feed it a specific input, a specific calculation happens inside the box as the rule, and then it spits out a specific output. And honestly, the incredible thing here is that those built-in tools you already rely on every single day, they are the exact same kind of object as the ones you're about to write yourself.
Which brings us back to that question. Why build your own machine rather than just borrowing someone else's? Well, it really boils down to two main reasons. First off, the specific formula you need is often way easier to just state yourself than to try and find buried deep in some dense library somewhere. And second, scale. If you know you're going to run the exact same calculation across hundreds or thousands of inputs, you just write the rule down once and let the machine handle all the heavy lifting.
Plus, when you build your own machine, you gain total control over its efficiency. You do this by assigning default inputs, which, by the way, is a very deliberate design decision. By setting a default, you guarantee that the ordinary everyday case is super short and easy to call. But because that input is still technically defined, your unusual edge case scenario always stays reachable if you ever actually need to overwrite the default. It's the best of both worlds.
Another massive advantage here is inspectability. Because think about it, how do you actually trust your tool? Well, when you take a calculation and you give it a name, you make it inspectable. You can run it against a known value, meaning an input where you already know the exact answer. If the output matches your expectation, boom, you have instantly verified that you wrote the exact math you intended to.
Let's try to ground this whole concept in a machine so simple it is almost trivial. Let's look at one that literally just adds two numbers. It is three basic steps. Step 1, your input is two numbers. Step 2, the machine calculates the addition. And step 3, it hands you the specific output on the other side. That's the whole shebang.
Now, you might be wondering, why use an example that is almost insultingly simple? Well, it's because the machinery absolutely has to be visible before it gets loaded up with complex statistics. Think about it. If we started off with some crazy exponential failure function, you'd be fighting to decipher the math and the underlying mechanics at the exact same time. But with simple addition, every single gear and lever is completely visible right from the start.
As you go about building these tools conceptually, you really need to know how to evaluate your output. A mathematically sensible result is just a predictable output from known inputs. Basically, it behaves exactly according to the mechanics you designed. On the flip side, a suspicious result, well, that is when the output completely defies your known formula. And the beauty of this is, when that happens because you built the tool yourself, you know exactly which machine to open up and inspect to fix it.
Which actually brings us to the absolute biggest trap you can fall into here. Do not treat custom functions as some special, super complicated technique that you can just put off learning into later. This is not an advanced move to defer, it is simply the ordinary, everyday way to write a formula down once. So I'll leave you with this question. How much time are you really willing to waste doing things the hard way before you let this tool stop feeling special and just start using it?